Hello and welcome to another exciting episode of Dr. J's Web Tech Lectures. This one will serve as an introduction to JavaScript. So first of all, a little bit of background information. JavaScript, since its inception in 1995, has been primarily a client-side scripting language or client scripting language. The code is downloaded from a web server and executed by the browser itself. So that's why it's considered client-side, not server-side. It's not executed on the server. Except for minimal competition from VBScript in the late 90s, JavaScript has had no real challenger. All major browsers have a JavaScript engine in them. Relatively recently, however, JavaScript's found a place outside of the client-side scripting. Node.js, since 2009, has been a very popular back-end runtime environment, executing code outside the browser. So it uses a JavaScript engine, but it doesn't do so inside of a browser context. And then other technology, Electron, just since 2013, although that may seem like a lot of time has passed for both of these now, these are relatively young technologies. But they've been around long enough that they've been able to develop a good support framework, and also they get debugged really easily. So another thing that the Electron is known for is that it was created by GitHub, and I should probably mention it was for development of desktop GUI applications, primarily any desktop application really, but primarily for the desktop GUI application. And it was created by GitHub, the company that makes the source control management system, to make their text editor Atom. Get it? Because atoms are made of electrons? Right. That's really funny. Okay, so Visual Studio Code is built on top of Atom as well, using the Electron framework. So I would probably say it's built on top of Electron using some of Atom's source code. So client-side JavaScript. So we're focusing for now on JavaScript's primary use as a client-side technology. So the three technologies are considered crucial to understand in order to be a front-end developer. These three: HTML, CSS, and JavaScript. So DOM scripting, the way this works, the document object model scripting, when a browser receives an HTML document, it interprets the markup and creates objects in memory representing parts of the document. So this collection of objects that it creates from this HTML document, it just parses it and basically creates different objects in memory. Just like objects can be created in other programming languages, it does so for JavaScript. We have the objects in memory for the document object model. So you have the root element that is the HTML element, and it has reference to the head element and then the body element, and then both of those can have stuff underneath, like the title or the meta char set. Body can have H1s, anchor tags, paragraphs, whatever. So much of JavaScript does to create dynamic behavior, much of what JavaScript does, I guess we'll change that. Much of what JavaScript does to create dynamic behavior is to change the DOM in a process called DOM scripting. So here's an example. So if I use this syntax const h1, I create a constant h1 variable, or constant to be more precise, which will hold the address of the h1. In this case, I query selector and I say h1. If there's more than one, it will grab the first one. There's also a query selector all, but this uses the same selectors, as the name suggests, as CSS would use. So the fact that in CSS we can use just the plain element type selectors like body and h1 and a and input and things like that, you can also say I only want h1 with this particular class, or I want everything with this particular class, or this with this ID, etc. So you can do all that with query selector and query selector all. If there was more than one h1 in a document, then that would mean that query selector would just grab the first one. Now what we would do here is we can set the inner HTML. This is the content of an H1 being an element with two tags. It's got an opening and closing tag. The inner HTML is new heading info. And you could also put HTML in here. You could put like EM for emphasis or strong to make it bold or whatever you'd like. A little bit of history of JavaScript. So ES1, the very first edition that was really released is 1997. So it's been around for quite a while. This is the first ECMA standard. ECMA is the group that manages the standard for JavaScript. And you can keep going. You'll notice ECMA script 4 was not released. 5 was released in 2009, almost 10 years since the previous version had been released. And that brought with it a lot of different cool additions and things like that. That's referred to as ES5. You'll typically see that. But its formal name is ECMAScript 5. ES6 is ECMAScript 2015. That's a little confusing for people because they see the 15, they're like, is that the same thing as, you know, if they say ES 2015 or ES6, those are actually the same thing. So this brought major changes. It added the let and const keyword, default parameters, and many, many other features. Now, since then, they've tried to keep a release schedule, and they've been pretty good about it, keeping a release schedule of new features every single year. Now, that doesn't mean that browsers will immediately support all of the new features, but all the browsers currently support, at bare minimum, they're going to support pretty much everything in ES6. Now, you could say that the 2016, a lot of people will refer to that as ES7 or ES8, but that's falling out of favor for just naming the year and using the formal name. So you might say ECMAScript 2016 or just ES 2016, right? And then 17, 18, 19, 20, 21, etc. So some syntax, basic syntax we're going to use with JavaScript. Identifiers are the names given to variables and functions. We have to remember that JavaScript is case sensitive. So uppercase and lowercase letters that are used in identifiers are treated as different letters. So these examples are all different. JavaScript identifiers cannot contain white space. So my space name is not a valid identifier. JavaScript identifiers can't start with a number. So if you call it first person or something like that, you can't do that. It can have numbers in it, but it just can't be the first character. So if you say something like my first person, that would be okay. A good coding convention to use, although it's not required, like the other things are required, is to use descriptive names with camel casing for identifiers. So if you're not familiar with camel casing, it basically means that you start with a lowercase letter, like M in my, and then every time you come across a new word or partial word, then it would be like the hump of a camel, right? So it's my name, right? Instead of my name. Okay, could it be my first name? Then it'd be my first name. So all three of these, you would have the M as lowercase, the F as capitalized, and then the N as capitalized. Since we can't put spaces in here, this makes it a lot easier to read rather than something like my first name, like all the way across. This is especially true for even larger names. Some statements you should be familiar with. JavaScript statements should end with a semicolon, and they look like this. So a const and then like some variable name equals 15. That would be a constant numeric value, specifically an integer. You have const versus let versus var. For years, var was the only keyword used to declare variables in JavaScript. But as of ES6, ES 2015, let and const are now available for block scope, and they should be preferred over var in most cases. The var variables are globally scoped if a var variable is declared outside a function. If it's declared locally inside the function, then it's locally scoped. If you forget var altogether and you just put the name of a variable you haven't used before, then it will get hoisted as a global variable, which can be very confusing. So always remember to use a keyword var, let, or const when you're declaring a variable. Let and const are both block scoped. In other words, they live inside sets of curly braces if they are declared in there. If they're declared at the global scope, then they're global, of course. But let is the preferred keyword for variable declaration. And then const is just like let, except it doesn't allow the value to change. So const objects, in this case, being used as a string, we have const name equals, and then John Baugh in double quotes. That's a string, but if I try to change it later to name equals Bob Robertson or something like that, that's an error because it's a const. However, we can declare objects using const, and the properties of the object can still change. Now, we'll learn about more about objects in later lectures, but you'll notice that I have this, and to create an object, just like with a string, it takes double quotes to declare a string. To create an object in JavaScript, you can create one that's just on the fly, basically with curly braces. If you put curly braces there, it automatically creates an object. If you put an empty set of curly braces, it's just an empty object. Now, this would be an object with 3 properties: the name property, the age property, and the weight property. So it says age is 20. My name is John Baugh, age is 20. That's a little bit low. And then my weight is 200, also slightly low. Later on, you could change the properties thusly. Even though the actual object is a constant, I can't point to another new object or anything else with it. I can't say John data equals Bob or John data equals a new object. I can't do that, but I can change the properties. They are not constant. So I can say John data dot name equals John P. Baugh. Maybe I'm updating it. And then John data dot weight equals 220. A little more accurate. Too much Buffalo Wild Wings, right? So hoisting. So this is something that we need to understand where variables are concerned. Hoisting, all variables and constants are stored in memory by JavaScript, the JavaScript engine, when the code initially loads. Let constant var variables and constants are stored in memory first. The variables and constants are hoisted, meaning it appears as if their identifiers were moved to the top of the JS code. So var declared variables are initialized to undefined. So this is another difference between let, const, and then our old friend var. Var declared variables are initialized to undefined after they're hoisted. So that means that the var variables are always accessible. Let and const declared entities are not initialized when they're hoisted. So they can't be used until they're initialized. So let and const are only accessible once you have explicitly initialized them with some sort of value. Otherwise, they throw errors. So it's not a syntax error. It's going to be actually a runtime error. So here's an example. Set of examples. So example 1 with var. If we do console.log myvar, even though I've declared it later, this will actually print out undefined because myvar was hoisted above where it's used. And then when we print it there, it knows that that variable exists. It just doesn't have a value yet. Then here, it knows that we intended to set its value with a declaration right there. So it will actually store John. And then when we go to console.log or what have you, it will print John. Example 2, for let, if we try to declare a variable mylet here and set it to John, just like with var, we can do that. But you'll notice if I try to print it out or use it before it is declared, this was not hoisted with a default value. Not even undefined. It's not anything. So this actually creates a reference error and says, hey, this thing isn't actually a valid reference yet. So let mylet equals John, and then console.log mylet, then it will display John because now it's been initialized. Okay, data types and operations. So loose typing. Many languages, such as C++, Java, C#, are strongly typed. For example, int my age equals 20, string my name or capitalized string my name in Java. You have that equals John. JavaScript, on the other hand, is loosely typed. The type of variable can change throughout its life, unless it's a const, of course, because then its value can't change, so obviously its type can't either. But if I say let some data equals 100, then it will hold a number, in this case an integer reference. Some data equals John Baugh, now it holds a string reference, then it can hold an array, then it can hold an empty object, then it can hold even a function, because functions are considered first-class citizens in JavaScript, so it can actually point to a function quite easily. If you're coming from C#, that's like a delegate kind of, and if you're coming from C++, then that would be like a function pointer. So here's some data types. This is a little bit harder to see, so I'll zoom in. JavaScript has 7 primitive data types. These are fixed size and stored on the stack instead of the heap, okay, which are different areas of memory, obviously. The stack, if you're familiar with other programming languages, the stack lives in the function call stack. The data, the memory is allocated for each stack frame every time you call a function, or every time something comes into memory. You get allocated all this memory at compile time, or at earlier time in these with these languages, so that when you run the program, it's already predetermined that you're going to get this amount of memory in order to store the stuff on the stack. Whereas heap data lives in a special area of the heap, which just holds dynamic data, meaning data that you've allocated at runtime. So these are the primitives. These are stored on the stack and are fixed size. Number, this can be an integer or decimal values, so real numbers. Boolean can hold true or false. Strings can hold character data. Symbol is a unique value that can't change. We'll probably touch on that later in the course, not this lecture. Undefined means the value hasn't been assigned yet. The actual keyword is undefined, but it's lowercase. Null value, also lowercase. It just means there's no value. So there's a difference here. One is value hasn't been assigned yet. The other is no value. It's no value at all. And then there's big int. This is an extremely large or precise integer value. Okay, moving on. Operations. There are 3 major categories of operations that we encounter in JavaScript. They are the arithmetic, relational, and logical. So I won't belabor this, but you see that there is a table here of the different symbols we can use. And you notice that JavaScript does in fact support the modulus operator, which gives us the remainder. So if this variable sumVal over here is 9, then the remainder is 0, because 9 divided by 3 is 3 with a remainder of 0. If it's 10, 10 modulus 3, 10 divided by 3 is 3 with a remainder of 1. So that means that the modulus operator would return 1 in this case. Plus plus and minus minus, the increment and decrement operators respectively. If they're on their own lines with no value set equal to them, or multiplication or any kind of thing like that going on, then x plus plus and plus plus x, those would be the same thing. Y minus 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 y, whether it's the prefix or the postfix versions, it doesn't matter if they're on their own line. Note about strings. When used on strings, the plus and the plus equals, which is a compound operator, are not considered addition or addition assignment operators. They're acting as concatenation operators. So we don't ever say we're adding 2 strings together. Get out of the habit of saying that if you use those terms, because it doesn't sound like you know as much about what you're talking about. So it's much better if you can say we're concatenating these 2 strings. So in this case, what I'm doing is I'm using the compound operator, which as an arithmetic operator is just the addition assignment operator, but here it's concatenation assignment. So let my name equal John with a space here, and then my name plus equals Baugh. That just allows us to concatenate Baugh to the end of my name, and there you go. I'm going to open up a browser here, and just real briefly, if you hit F12, you will note that it loads this console over here. We could actually clear the console here, and you can kind of play around with JavaScript here. So if I say console .log hello world and hit enter, it will say what the return value was, which is undefined because it doesn't return anything, and it just prints to the console hello world. This is kind of for debugging. This wouldn't actually appear in the web page. It's mostly for debugging purposes. Now if I do something like this, let my name equal, I wonder if I can get this a little bit bigger. That's quite a bit bigger. Let my name equals John with a space, just like I said before. And then my name plus equals. You notice it actually recognizes it. As soon as I do plus equals, it shows us what the value is. If I say plus equals Baugh, it's John Baugh. And then, of course, console.log, if I log my name and maybe concatenate is awesome, then I get John Baugh is awesome. And, of course, console.log doesn't return anything again. Good. And, of course, there's the other things, too. You can do let some value equals 5 plus 6, and then some value is 11, right? Plus equals 12. Now, in this case, we are not concatenating. We are adding. We're using the addition assignment operator, and we get this value here because we get the original 11 plus the 12, and then we get this 23 right here. Pretty cool, right? Okay, back to here. In addition to the arithmetic operators, remember we have 3 different major categories, the arithmetic, relational, and logical operators. In addition to the arithmetic operators and the concatenation operator, which is kind of a side thing, we have relational operators. And in JavaScript, there's actually a larger variety of relational operators, but the equality operators and regular relational operators are probably what you're used to from other languages. And these are, right here, these operators that don't include the equality operators are going to be the same. We don't get 2 different versions of those, but we kind of get 2 different versions of these, which I'll explain in a minute. But notice that equals, the equal to and the not equal to operator, equal returns true if the operands are equal, and not equal, obviously, if they're not equal. If you look at the example over here, if I have my num is 1, which is the integer 1, okay, zoom in a little, this is the integer 1, let your num equal, and then make that the number 1 as a string, okay, if I express the relational operation here with the left operand being my num and the right operand being your num, it will actually return true, even though they're different types, right? So that should maybe go on the next line, but even though they're different types, it recognizes that their values are true. Now the way it does that, just as a heads up, is it actually does a type coercion. So it's able to compare these values that way. Same thing goes with not equal to. These are fairly straightforward, so I didn't put additional examples. Oops. But A greater than B, A greater than or equal to B, A less than B, A less than or equal to B. So you're probably familiar with those from another language. And if not, you're familiar with them from mathematics, except usually we draw this one as greater than or equal to with like a line under it. But since we don't have a single key that makes that symbol, this is how you do it with JavaScript. Moving on, more relational operators. These are the ones that I said you have kind of different versions of equal and not equal. But they're actually not just equal or not equal, they're strict equal and strict not equal to, or identical and not identical. They're the identity operators. So the triple equals, this may seem like kind of funky syntax if you're used to another language, but if you're not, then this is kind of brand new anyway, so it doesn't matter. But the triple equals is for comparing 2 values, but also not doing type coercion. So this is actually preferred. It's actually slightly more efficient because it doesn't perform any type coercion. And if we go zoom in here, my same example from before with the number equal to the or with my num equal to the number 1, and your num equal to the string with the 1 character in it. Now, if it was double equal sign, equality operator, then it would say, yeah, those are the same thing, because it performs coercion from one type to another. Here, it returns false, because it doesn't try the coercion. It actually doesn't even need to try their values. It just looks at them and says, those aren't even the same type, so definitely false. That's what it would do. So now if I had another num equal to 1, and my original my num is 1 also, and these are the same data type as well, then this will return true since both the types and the values match. Behind the scenes, what it's doing is it says, do the types match? If the answer is false, it doesn't even bother checking the value. But if it knows that the types do match, then it checks the underlying value and determines whether those values are true or not. So we've got arithmetic operators, we've got the relational operators, and now we've got the logical operators. This is the third major category. These work largely the same way as they do in many other programming languages. So and, or is the two bars. It's right above the enter key if you hold down shift on a typical US keyboard at least. It's usually on this. It's generally on the same key as the backslash. So you just do it's also known as pipe. If you do 2 of those, that's the or. And then this one is only 1 keystroke. That's just the exclamation point or the bang symbol. These first 2 are binary operators, which means that they each take 2 operands. And then the final one, not, is actually a unary operator because all it does is it swaps the truth value of the thing it's being applied to. So P and Q is true only if P and Q, whatever those are, they could be variables, they could be expressions, they could be other logical operations, they could be relational operations, they could be a method call, anything. If they can be evaluated to Booleans and both of them are evaluated to a true value, then the whole thing is true. Or says if at least one of these is true, then the whole expression's true. And then for not, since it's a unary operator, it looks at P and says, well, whatever P is, I'm going to flip its Boolean value. So if P is true, not P is false. If P were false, then not P is true. And of course, I would be remiss to not include the truth tables. This is for logical and, this is for logical or, and this is for logical not. Now obviously in JavaScript you have the actual values true, lowercase, and false, lowercase, which are values. But here we're just using T and F to indicate if you have both true, then the whole thing's true for and. But if you have the first one's true and the second one's false, the whole thing's false. First one's false, second one's true, whole thing's false. And then if both are false, it's also false. So the only time it's true is when when both the P and the Q are true. Logical or is a little more forgiving. You'll notice that the result is always true unless all of the values, or both of the values being compared are false, or combined are false. Now, logical not's very easy. Being unary, we don't even use a Q. We just have, our P here. If P is true, then not P is obviously false. And clearly, if P is false, then not P is true. Now, JavaScript has a peculiarity, and this is going to really, really bug some programmers. When I first came to know about it, it was really irritating. And I didn't like it at all. I didn't like the idea. I thought it opened up way too many cans of worms. But this is kind of what you get when you have a language that is loosely or weakly typed. You get things like this. However, it does have great advantages, which hopefully you'll learn about throughout the semester, and you'll learn to accept it. Even if it does have eccentricities and problems, hopefully you can learn more to like it. So what am I talking about? What I'm talking about is this peculiarity that most programming languages do not have, and this is the existence of what is called, and these are not words I have made up. This is Truthy and falsey values. So in other words, we can treat non-Boolean values as Booleans in certain expressions. So in Java, I might have to do something like this. If I have some object or something I'm doing a comparison with, I could say my object not equal to null, right? Example in C++ would be my object not equal to null pointer. In JavaScript, it's a little bit different. You'll notice that I can directly, even though my object is not a Boolean, I can just say not my object. And what that means is my object, even though it's not a Boolean, if it takes on any of the what would be considered truthy values, then not true would be false, not false, falsey would be true. So if it was used in a Boolean context, this would be equivalent to not, or rather it would be equivalent to my object not equal to null and my object not equal to undefined, my object not equal to the empty string. It could be all sorts of things like that. Anything that could be considered a falsy value, right? So in this case, it's just saying this is a very easy and good way to say, does my object exist? Okay. So again, these are the non-Boolean values interpreted as false right here. So 0 is interpreted as false. The empty string is interpreted as false. Null, undefined, and even an empty array are considered false. Non-Boolean values interpreted as true would be any number other than 0, any non-empty string, any non-empty array, any object, and any symbol. Moving on, we have strings and dates. So interesting string basics. Strings work mostly as they do in other programming languages. However, both double quotes and single quotes work for either circumstance. So let my name equals John. Notice I'm using double quotes here, but you can also do it with single quotes. It's totally fine. In many languages, single quotes mean just a single character, but we don't really have a single character type that we articulate in Java differently than a regular string. So this is what you get. Okay, so you can have a single quoted string here, or double quoted, and then in addition to concatenation, which we saw earlier, you can use a really interesting and cool feature in JavaScript called string interpolation, using template literals. So a template literal uses these marks right here instead of the double quotes or the single quotes. A lot of people, when they see it at first, they think they're the same exact thing as the single quotes, but they are not. They are on the standard keyboard. They are on the same key as the tilde in the upper left next to the 1 key on the keyboard. It's to the left of the 1 key and right above the tab key, typically, below the escape key. The tilde is like this little squiggly key right here. So this, if you don't hit shift and hit that key, you get the, some people call it the grave symbol or grav symbol, and the tick mark. It's different names for this thing. But that's how you declare a template literal, using whatever you put in between these types of quotes. These tick mark quotes will denote a template literal. And if you don't put any special consideration or special things inside of them, rather, it will just act like a regular string. However, we can do something like this. Let's say I create a variable called some name, and it's set to John Baugh, regular old single quotes, so it's just a string. And then I say let another string equal, notice there's tick marks here, so it's the template literal. And I say hello, and then something, and then how are you? That's all regular string, but notice this part. This is where the string interpolation occurs. So the string interpolation occurs with it's special syntax to indicate that, hey, there's something special here. $, and then curly braces. Inside the curly braces, you can actually put any kind of expression, but a variable name is acceptable. So it'll actually print out, hello, John Baugh, how are you? If we go back over here, I'm going to clear this. We'll do something similar. We'll say let some name equal, I'm going to zoom in just a little bit more. We'll do single quotes. Doesn't really matter. Oops, that wasn't good. Single quote. Okay, I should put a curly brace, so let's fix this. Let let some name equals John Baugh. There you go. Now it says undefined because this isn't really returning a value, but if I type some name, you can clearly see that John Baugh is inside of it. If I say let message equals, and then I put a tick mark and say hello, and then put some name, exclamation point. I'll put another tick mark and a semicolon, and then do console.log the message. It will, in fact, use the string interpolation, take the original, put some name right there, and then put hello, John Baugh. Pretty cool. So, moving on, some useful methods and properties. Well, there's really only one property of our strings, and that would be the length property. So the length property, if I say const name equals John, you could use let, but if I don't plan on changing it, we'll use const. If I say const name equals John, which is clearly 4 characters long, if I then print out the length, it will print out 4. 2 uppercase and 2 lowercase probably do what you expect. They return a new string in upper or lowercase respectively. So they do what you expect. I don't know if I said that right, but substring is another one. There's actually a couple versions of substring, but the others are substr with no ing. But this is the primary version, substring here. You have to specify, or you specify a start index, and you can also optionally specify an end index. These brackets are not part of the syntax. This is just saying that the comma and then providing an ending index are optional. Okay, so just keep that in mind. The end index is exclusive, so that means if I put from 0 to 10, it will include characters 0 through 9 inclusive. So start index is inclusive, end index is exclusive. If not specified, substring returns a new string from start index up to the end index. It says if, I should put if end index is not specified, right? So if that's not specified, then the substring returns a new string from start index up to the end. So index of, this returns an integer given a search string, and you can optionally also say start searching from some particular location or index within the overall string. This will return the index of the first character in the search string. So if I look for, if I go over here, and I've already got this hello message here. So if I say console.log, and I say message.index of, now notice there's a last index of 2. This actually is really helpful. When you hit F12, it brings up the developer tools in any of your browsers. I just happen to like the one that's built into Chrome. And also, just as a note, make sure you're on console if you're messing with this. If you go over to Elements, though, it's kind of cool too. You can see what's going on. But since I'm on Google, I'm not editing their code. I don't really care. But I'm looking for the first index, or the first location where O occurs, right? The O string. And notice there's hello, but there's also John. So I should get this first O here, which is at 0, 1, 2, 3, 4. And I do get indeed 4, right? Now, if I tell it to console.log the message.substring starting at message.index of the O, let's see what I get. Oops. Looks like we're missing something. Yeah, sorry. We have too few of those. Okay, so it just says O and then John Baugh, right? Because it started at the index 4, and we get a new string starting at that all the way to the end, which includes my name. Pretty cool. Moving back here. So other things that we have are the other substring version of substring. This one is not spelled out. This one has a start index, but also gives a length instead of an ending index. So this is actually more for convenience than anything else. There's also char at index. Given an index, what character lives there. So if I go back over here and I say char at 5, you can see that's the comma. And that's pretty much what we expect because the message itself is hello John Baugh. So you could do 0, 1, 2, 3, 4, 5, and that's our little comma there. Perfect. Includes gives us the ability to do some searching. Again, you can have the start index as I mentioned. Many of them are like this. So it returns true if the search string exists, and optionally, again, you can say where do we start searching from. Trim returns a new string with both leading and trailing white space removed. So let's say that we take in input from a pop-up. So a prompt, I'm not sure if this will let us do a prompt. Let's see here, prompt test. Oh, it does. Okay, that's good. All right, so we'll do that in just a second. So we've got the parse int method that allows us to take a string and attempt to parse it into an integer. So if we let some input equal to the value that's returned by the prompt, you can see that that allows us to enter something, and then we can take that and parse it into an integer and do stuff with that value. So parse int and parse float are useful for string to numeric conversion. And we also notice another interesting thing about this. You'll notice that this right here held a string by the end of this line, right? Because enter your age, anything prompt returns is actually going to be a string. So it will accept any string as input and returns that string. So some input is a string. Then some input is changed to, rather, the parse int on whatever that string is and returns an int. So we can see that we can reuse this variable and set it equal to a value with a completely different data type. Okay, so as long as it's a let, we can do that. So let's clear this. Let some info equals prompt. We'll say, what is your weight? Okay, and then the pop-up comes up and says, what's your weight? Let's say 220. Okay, and then let's say, if I try to do something like this, if I say some info plus 20, notice what it does. Do you see how it just concatenates? It actually promotes it to a string and then concatenates the 20 at the end. Well, if I want to know, or, well, let's say losing 20, it'll actually know to perform that, but it's, if I want to do any kind of arithmetic, you should convert it first. So some info equals parse int on some info, and now you'll notice there's no quotes around it, right? So I could actually say some info minus equals 20, and then that gives me 200. So if you lose 20 pounds, yay, you're 200 now, right? Pretty cool. Continuing along, we have dates in JavaScript. This is another type that we might find useful. If you get the current date, so if I clear this here, const will say current date equals new date, and then current date, you'll see this actually has quite a bit of information in it. It's showing us what its entire contents really is. But if I say something like dot two full year, or wait a minute, get full year rather, it'll just return the year, right? So we know it's going to have a lot of methods on it. So let's see what happens, or let's see what we have available to us. I could use a date string, or I could use a constructor with a lot of numeric values. So right here, I could just have it parse the string using the more the local version of the string with the month slash day slash year. And you can also include things like times if you want. This would be specified in military time, of course. But you can also use numeric constructors. So you can say new date equals year, month, day. So the order is different than what you might expect. Year, month, day, hour, minute, second, millisecond. So it basically goes from largest to smallest. Now, one thing that will be a little bit irritating, if we do, for example, current date dot get month, now you'll see that the current date says 8, even though I'm looking at this while it's September. Okay, so that's because it is 0 indexed. So that means January is 0, February is 1, March is 2, right? April's 3. I'm sorry, January, February, March. Yeah, March is 2, April is 3, May is 4, right? It's easy to get confused with that. So you need to remember to add 1 to it if you want the standard value. And also when you create a new date and you specify the month value, 2 is March, 0 is January, 1 is February. Okay, so it goes from 0 to 11. Other things you can do with dates, I've showed you a couple of them already, so I won't belabor the issue too much. But you can get the full 4-digit year, you can get the month, which is 0 based. You can get the date, which will return the day of the month. Get day, that returns the day of the week. So if I say current date dot get day, that returns 1, okay, because it's now actually a Monday and it starts on Sunday, 0 Sunday. And current date dot get date is 6, and it is in fact the 6th day of the month. So you don't have 0 based on that. It is actually September 6th. Not surprisingly, you have pretty much all the other stuff that you expect. You have setters for the majority of those getters as well. So set full year, set month, set date. So if I wanted to change the year that a date represents, you can do that too. So you can say current date set full year to 2030, right? Now that's actually giving you a number of milliseconds since January the 1st, 1970. That's how it actually internally stores that data. And it uses that to determine what is the actual date. Now if I say current date, you'll notice that the current date is actually set to a completely different day, September 6, 2030, and we know it's going to be on a Friday, in case you were curious. All right, so current date dot get full year, and of course that gives us more information there too. Good. Control statements. So if you're trying to find maybe a place to end for now and come back later after you've had a little bit of time to absorb the material, control statements might be a good stopping point. So really any of these sections you could stop and then come back later and try to absorb some more. But if you want to go all the way through, obviously that's fine as well. Now, control statements are useful for, of course, controlling the flow through a program. And we need to remember a couple things moving forward from what we learned previously, is that we have equality operators and we also have identity operators. So the equality operators work great for comparisons where implicit type coercion is acceptable. And I give an example again. And identity operators are preferred. They don't perform type coercion, so they actually are, they're more precise, and they're also more efficient because they don't perform the coercion. So when when you're using all numbers or something like that, it really makes more sense to use the identity operators, and those are preferred in JavaScript. So just get used to that. The control statements that we have available are actually, there's 3 categories of control statements. There's sequential, selection, and repetition. Sequential, selection, and repetition. That's true of essentially any imperative language or object-oriented language with imperative base. You're going to have sequential, which is almost always the default. That means lines of code are executed in the same order in which they appear linearly. And you could put a caveat and say within a particular function, or at the global namespace in JavaScript's case, either in a function or at the global namespace in the file linearly. So selection control involves selecting a path of execution. We have 3 selection control statements, specific syntax. We have an if statement, you have the if-else statement, and you have switch statements. If statements mean you can execute the code in the if statement block, or you don't. So it's basically you do this or you don't do it. If-else means you can execute the code in the if statement block or the else statement, and those can be chained. So you can say if, else, if, else, if, with new conditions. The switch statement is executed one block of various options, okay? So I'm not going to cover all of these. I'm just giving everyone kind of an overview, and we'll dive deeper into them as needed as we go throughout this course. So that was the sequential and selection repetition. We also have, sequential and selection control statements. We also have repetition control statements as well. I'm going to make that second one lowercase just to be consistent. Repetition control involve repeating a block of code based on a condition, such as the while, do while, or for loops. Some basic syntax here. So we could have, this should probably be, more like that. So for let I equals 0, so if you're coming from a language like Java or C++ or C#, you're probably really tempted to put something like, int or something like that, but don't do that. You're just going to say let I equal 0, I less than 10, I plus plus, right? And then we can print out even or odd. So over here, if we clear this, I think this should work okay. Let's see, let I equals 0, I less than 10, I plus plus. And I'm actually holding down shift. If I modulus 2, we're going to do that, and then else. Okay. Console.log, you could say I, and then say is even. Then down here, you could say I, and then is odd. Good. And then, of course, it loops. Starts at the beginning with I equals 0, and prints, it goes here, and, oh, actually, you know what? This is kind of actually a mistake here, but it still works. This is kind of wacky that it still works, but it's because of that truthy falsey situation. You should do this, though. But it's the same. It's ending up as the same thing, but this is actually more appropriate. So we'll do that. There we go. So the I modulus 2, what happened before is, since 0 is considered a falsy value, if the I modulus 2 returned to 0, it actually ended up still working perfectly. It's kind of an interesting JavaScript-y type thing. This would not even compile in other programming languages. But this is a little more readable. It's a little more clear what's going on. I'm saying if I modulus 2 is 0, meaning it has a 0 remainder after I divide it by 2, that means obviously it's even. So if it doesn't have a remainder of 0, in this case it will be a remainder of 1, it'll print out that it's odd. And it's not surprising. It keeps going through the loop, and it'll keep going until it gets to 9. 9 less than 10. 9 modulus 2 is actually 1, so it'll print out 9 as odd. Then go up again to the loop with the I++. It'll be I is now 10. 10 is not less than 10, so then it breaks out of the loop and continues. All right. Perfect. Another method you should be aware of is that since there are literally unlimited values that could be not numbers, then to detect if something is not a number, you need to use isNan. Okay, now it's a little bit weird because the syntax is a little strange. It kind of does camel case, but the is part does. But then when it gets to not a number, it actually takes the acronym and puts it almost in kind of like a title case acronym. It's very strange. So that last N there has to be capitalized. If you put is nan like that, it will not work. It'll say, I don't know what that method is or that function. So right here, if I have a function get value of some num, and then if is nan, if it's not a number, oh, this is should have an extra parenthesis there. If it's not a number, then I return input must be a number, and then otherwise, if it gets past this if statement, then it returns maybe the number times 100. So it can return, this one can return a string or return the integer result. Pretty cool. All right, now on to examples and exercises. I will go through the example, but the exercise I'll leave to you to try to experiment with and explore on your own. So this is a really, really bright, but this is the actual solution to the code. So maybe I might want to change the font color a little bit so it's not quite as offensive. There we go. So this is the zip of the code on a Google Drive. And this is a simple web application to calculate the cost of ice cream. So there are 3 flavors available, vanilla, chocolate, and strawberry, all $1.25. You would use a drop down to pick the ice cream flavor. Topping options, 25 cents for cherry, 25 for nuts, and use a checkbox for the toppings there. Create a button to click to trigger totaling of the cost. And then my hint was use inner HTML. And then if you want the solution right away, you've got the zip of the code here. Make sure to unzip it before you try loading the code or it won't work correctly. Okay? Okay, so what I have in VS Code over here is I have a folder, empty folder here, that I've gone to open folder through VS Code and just established here. I'm going to use styles and also scripts. I'm going to create a new file here, index.html. That is the default file that we want to open. I'm going to go in here just so we know that we've got our file here. This is index.html. It's currently empty. It's not really doing anything. We'll leave that there. And now I'm going to fill it in with some HTML. So we're going to do the doctype HTML. HTML lang equals English. Some people would prefer to use the dir for direction of the text, which is left to right in this case. And we're also going to have the head and also the body. Remember, of course, with HTML, HTML has only 2 things inside of it, the head and the body. Then inside of those, you can have things like title. So this could be something like ice cream shop. Fun. Old school or old-timey spelling of shop. And then we can do something like this, meta charset equals UTF-8. Right? That is an empty or void element, so there's no closing tag. Inside of body, maybe I'll make a main here using the main semantic element. Inside there, I'll put ice cream shop or ice cream purchase, I think is what I did originally. So I'll do that again. And then I have sections. I have it divided into sections. You could use articles, you could use divs. Doesn't really matter in this case because there's not really anything perfect for this. But I'll have a label for flavor. Now I have to have something that actually has the ID flavor. So it's going to be a selection. Remember, we want a drop down, so that's what the select does. Option value equals vanilla. Vanilla. Option value equals chocolate. We have chocolate. Option value equals strawberry. And we have strawberry. So if we wanted to, we could actually use the value of the flavor that was selected. For this particular example, we're not really going to worry too much about that. But we could use that value and say, hey, thanks for buying vanilla ice cream or something like that. So section, another section here. This time we'll have a label for cherries. I'm going to say cherries. This would be a topping. In this case, the toppings are actually extra. So we're going to have a checkbox for whether they want the topping or not. This one has an ID. We also have another section. This one has a label for whether the person wants nuts added to the ice cream. So give it the ID nuts. We also want to be able to submit this and also print out the output, right? So section type equals button, ID equals btn get total, value is get total, and I'll just leave that as its own section. And then I'll do a section here. The white space I'm adding is just purely just to keep these separated. The HTML does not actually care. So I'm going to put total here inside the span, but it has an ID of total, so that when we access it with JavaScript, we'll be able to know exactly which span we're putting the output into. So we're going to change the inner HTML to say something else. All right, so far, what does it look like if we refresh the page? So it's not particularly pretty. We're not really working for pretty right now. We're just kind of getting it functional, right? So get total is not doing anything. We can check these checkboxes though, which is cool. Now, if we would like, we can actually create, say, a style sheet. So under styles, I'm going to right click, new, main.css. And before I forget to do it, I'm going to link it in. So at the very top of the HTML, I'm going to put link, rel equals style sheet. Then the href equals styles slash main.css. And again, it is a void element, so there is no closing tag on that one. And now we'll go back to the main.css, and I'm going to style the section a little bit. So width 250 pixels, and then just give it a background color. That's really all I'm going to do. Just make it a little bit prettier, and or different at least. There we go. So it kind of stands out a little bit better. We could make the font bigger if we wanted to. It's kind of our whatever we want to do. Now, finally, under scripts, I'm going to create a main.js. And again, you can choose your names. Before I forget, I'm going to link this one as well. This one is not an empty element. Script type is text/JavaScript. And then the source is scripts/main.js. Pretty good. So text/JavaScript, and then the scripts main.js. So now I have to say what happens when we click that button, and what do I want to happen in general. So the first thing is we need a start function, and we'll learn more about functions later in the course, but this is kind of a chicken and the egg issue. So we have to know a little bit about them right now. And what I want to do is when I do add event listener, that says, hey, I'm calling load and calling start rather. This name doesn't matter. This name, window, does, and add event listener does matter. load matters because that's the name of the event specified as a string. Alternatively, you may have seen people do this. Window.onLoad. That would be equivalent. Okay? It's just a different style. So this right here in start, all we're going to do is we're going to associate the button, which we're going to grab by query selector. And we're going to use the same thing we would do to select it using CSS. So as you can see, btn get total has a pound sign in front of it. So since it has an ID, you actually could do document dot get element by ID, uppercase I, lowercase d, and then put btn get total with no pound sign. That would be equivalent. That's the older style. But this is, it's perfectly acceptable to do that. Some would argue it's maybe a little bit more efficient if you have an ID to do it that way. But this is the query selector, and it works perfectly well also. The button.add event listener. This time the event is not the load event. We don't care when the button loads. In this case, we care if you click it. And let's call it calculate total. We haven't created that method yet, so we'll create that, or function rather. Calculate total. There we go. And now this is where a lot of the magic will happen. So let total output equal document.query selector. We want pound sign total. That's the name of our span, right? The next things we're grabbing, we don't want the elements themselves, but we want their values. Okay, so for the flavor, actually I don't ever use that, so I don't really need to grab it, but I'll show you how to. Document.query selector, I could do flavor and then say .value. That would actually, it doesn't seem to be very happy with that. Why is it not happy? Okay, so that would be the way to grab the value right here, is just to say, hey, I'm grabbing the thing called flavor, which is this, and then I'm grabbing the value. Now when it gets a value, it's going to be one of these three things, right? One of these three values that's actually set. Moving forward, we have let cherries. Now this is a checkbox, so it's a little bit different. Document.query selector, and we're going to again go for the ID, but this time we're going to say, is it checked or not, right? So is it checked? Let nuts equals document dot query selector. This is going to be nuts, and then we're going to say checked there again, right? Because this and then the one in HTML, these are both checkboxes, right? Okay, so we're going to say set the total, which is the total price, if cherries, if it's checked. Since that's a Boolean, we can use it directly. It's actually, it's intended to be used that way since it's not just truthy or falsey, but it's actually a Boolean. We add the 25 cents in, so plus equals 0.25, right? That's the same as total equals total plus 0.25, right? 25 cents. And there are functions that we could use for localization to format this better, but we're just going to kind of do a bare bones printout. Specifically, in this case, not to the console, but to the span total output. Okay, so total plus equals 0.25 if they select that they want nuts on their ice cream. And now we output to the span. So total output dot inner HTML is equal to, and we're kind of got to rewrite total here. I'm going to put space $, just to keep it kind of bare bones. It won't put the correct number of digits all the time or things like that, but we could make that happen using some of the other functionality that we have at our disposal, but for right now we're trying to just keep it pretty simple. Okay, so internationalization, we can do some cool things with that. But right here we have vanilla, and if we say get total, you'll notice that it's $1.25 because that's the default. If I add cherries and get total, it's now $1.50. And if I uncheck that, add nuts, it's still $1.50. Without any, it's $1.25. And then with both, $1.75, regardless of the flavor. And I could, of course, print, oops, wrong way, kind of big, right? I could, of course, print the flavor as well, or thank you for your purchase of blank flavor. You could leave that, I could leave that as an exercise for you if you'd like. Now, so we've got all the code that you pretty much need here for this little project. I'm going to close that, and you can get this on the drive. For a challenge, you might want to challenge yourself with something like this. So I'm not going to solve it right here. But you want to try to create a similar app as our example, using it maybe just to kind of remind you how to do things. This time for maybe a pizza place instead of an ice cream parlor, right? So base prices, personal pizza, small, medium, large. You could use a drop down for those, right? And each of those has a different price. Toppings, pepperoni, ham, pineapple, onion, green pepper, black olives. You can make them whatever you want. You know, cut out the meats, make them halal, make them kosher, whatever you want to do. Make it your site, your website. Cost for each topping, personal, 50% or 50 cents for each topping you add. Small, $1, medium, $1.50, large, $2. And then there's a checkbox, it appears. Yes or no, garlic crust, that adds an extra 50 cents. And of course, we want to allow the user to click a button and get their total. All right, so that's pretty much what I've got for you for this particular lecture. I hope this was useful, and I will talk to you